Welcome back for my penultimate lecture in person. Penultimate, I have class after this. That will be the ultimate.
Wait, okay, how is this gonna work?
That's my next slide.
Hello.
Hi, Vanessa. So how is this going to work?
Not very well.
I think I'll do a good job.
Oh,
Oh.
you'll do a good job.
You'll do great with us.
I don't know about my grade. My grade will not be good.
I forgot to cross out this first line because I have the same basic plan for my classes, but you guys don't have reading assignments. So
God.
I was, yeah. You're what? Okay, so lectures. The lectures, I'll create the lectures on the Surface Pro and post them to YouTube just like I always do. So the difference will be I won't be asking questions and waiting for a response. I may ask questions to make you think about it, but I won't wait for a response if there's no class in front of me. And then I'll post them to YouTube. I will put them up. My goal is to put them up a week before the day that you're technically having that lecture. So you have some flexibility in time on when you watch it. Likewise, I plan on putting the homework up 2 weeks before it's due instead of 1 week before it's due, so you have flexibility time in doing the homework. So there's really no changes in the lectures and the homework other than me putting them up earlier and you not being.
Can I make a request?
You can, absolutely.
Every time we put up a new assignment, some of us don't get notified from Moodle, so just in a video, can you say, like, this will refer to homework 10 or something, like whatever, or just, I put up homework 10?
I want to make sure I understand. I think the answer is yes. I just want to make sure I understand. You want the lecture to say which homework this is relevant to that lecture? Mm-hmm. Okay, yeah.
Yeah, that'd be helpful.
Yeah, just want to make sure I understand the request so I do it right. Laboratories, I'll either give you dry lab data, like give you data or maybe show you videos of what should have happened, or have you do computer simulations for the labs. The labs is like I told Annabelle before class when she asked. I don't have that one perfectly figured out still. Exams, I will actually conduct one-on-one oral exams with you using Zoom or something like that. So what I will have is I will have a test form with the questions on it. And then we will arrange each one of us having a private time. And then I will ask you the question. Well, I'll have you use your phone or whatever to show the area around you, make sure there's not like your computer sitting in front of you or textbook open. And then I will ask you the questions. I can show you the paper so you can see them, whatever, and have you answer them, and then I will grade it, as we're going through. And it's actually a better way of assessing a student's learning because you can explore what they know and what they don't know instead of just giving questions and having I knew the answer to this, but not this. They can actually say that when you're having the oral. Whereas if you have a piece of paper, it's just, did you know these specific questions or not? Question answer.
So, talk me through that one more time.
Okay.
Because I was listening, but I'm confused.
So let's say that it is test time for Alex. So Alex will, first we'll have set up an arranged time that we're going to do this. So it's that time. We connect probably via Zoom. I haven't actually explored it because I'm apparently not a person. I should have. That's what I was assured. And so we will connect up, and I will have her use whatever device she's using to connect to show the area around her, just to make sure she's a blank table without her textbook and without a computer sitting there for her to look stuff up on. And then I will have a test in front of me. It's going to be a somewhat different looking test form because I'm going to be grading on it as well.
Comment.
Yeah.
You know in Zoom you can screencast?
I have not used it, so if you can screencast, I can
That
put it
means-
on half the screen.
That means that if we're video timing together, that means I can screencast my screen and you can see everything that's on my screen. You can't lock it, at least I don't think you can. I don't know, maybe you can, I don't know. But you could screencast so you can see what's on our screen and then I don't know, I guess you could still switch on the camera to show like what's around,
Yeah.
and then we would turn it back off, and I could screencast. We could screencast what's on our screen so that you can see what we're doing.
Yeah, and that's technology I need to
I
figure
just,
out.
honestly, I just always keep my hands visible.
What'd you say?
Very secret.
Yeah, and if you did it on a digital form, so like when we set up our time before, not even before, like immediately when we started Zoom, you sent us the email, we opened the document as we're screencasting so you can see what we're opening, we're not opening any tabs. And then it's kind of like an online assessment or like.
Well, I would prefer to have it on my screen and sharing my screen with you, rather than emailing. The reason is, conceivably, if I had a dishonest student, they could email. to
Oh,
somebody
that's true, I
else.
didn't even think about that. Yeah, you right, sorry. I wasn't thinking about that, my bad. So how would we answer it then?
And so you'll answer questions out loud. You can see the question, but you'll be answering out loud, and you have the freedom to say, no, I don't understand this, but I understood this part. And so you can share what you know if it's not a question I asked. Right? Whereas on a normal test, you don't have the option of sharing what you know, you're just, did I know
Okay.
the 7 things that he chose to ask me?
Is it just gonna be audio or well, Zoom's kind of visual too.
You can do it without the video,
I know, I just,
but then
But
if you
then-
have to see everything.
yeah.
Yeah.
You know.
I mean, the reason to see everything is just so you have a way of telling people, yeah, I made sure that it was, a secure test, not,
Yeah, no, I get
there's
it.
somebody in the
I
corner
just,
who's.
I don't know, it makes me
who's
uncomfortable.
the
I don't
answer.
like Zoom. I don't like videotaping. I don't like things like that. So it's just.
Yes.
Can we always go back, like if you remember an answer to something?
Yeah.
Okay. I'll just be like,
Yeah.
question 3,
It-
whatever.
Basically, the key is I have to not tell you if you're right or wrong,
Mhm.
because if I tell you you're right, well, we won't go back to that. If I tell you you're wrong, you'll be like, so I will try to be non-committal about telling you right or wrong, I'm just trying to throw what you know. And so the questions will be similar in nature, but I do want to emphasize,
Mhm.
you will have the ability to bring up things that are not on the test to show what you learned. Right,
Okay.
that's
And then
something
we
that
give us
makes it, I
credit.
think, far superior. Well, it wouldn't necessarily be extra credit, it would be credit.
Well, that's what I'm saying. It would give us credit.
Yeah.
Okay.
Yeah, so didn't know this, but knew that, but we didn't ask.
Okay. Oh, okay. I get what you're saying.
I'm assuming these-
Yeah. What about PTQs?
What was that?
What about PTQs?
PTQs, I would like you to, so I didn't put that up there because I didn't think about it.
Yeah,
I
that's
would
right.
like you to send me a PTQ from each lecture before the date that it's actually due. So, like I said, I'll have them up like a week beforehand, you can watch whenever you want. And then,
You said a week before it's due.
no, send me the PTQ by the time you're supposed to watch the lecture. So the lectures,
So let's say a lecture for Friday today at 10 a.m.
Yeah.
You would have posted that by Wednesday.
I would post it a week before.
Oh, okay. And you're saying you wanted us to turn in the PTQ for Friday by Friday.
Friday, right.
Oh, okay.
So you have you have a flexible schedule.
Yeah.
But we still have a deadline.
Yeah.
And so
Okay.
because
Yeah.
I'm still gonna use those in making the exams.
Are you gonna give us reminders?
Yes,
Okay, so I'm gonna forget.
that's down there at the bottom.
Are you gonna stay here or are you going?
I'm going home indefinitely.
Oh, education majors are required to stay on campus.
It depends on what you're doing in an education major, I think. The email said some majors might,
Okay.
like people who are in education who are doing practical. So if she's not doing practical, she probably doesn't have to. But if she's doing practical, she has to.
I'm not doing traffic. I only have observations and I have a classroom that I can do. So, yeah, I'm gonna be home indefinitely.
What was your question, Alex?
Oh, do you have a time thing of the TQs due?
Yeah, it's in the way. Those, yeah.
Okay.
And I think I can make a form on Moodle, you just type this on.
Yeah.
Okay, moving on down, office hours. I will of course be available via cell phone or email, and I will give you that contact information on Moodle. I initially had it here, then I realized I have more people who aren't students here that watch my YouTube videos than students here, and I don't want them to be calling me on my cell phone or, yeah. so on. So that's why it's not up there.
It'd be funny.
Yeah.
It'd be funny though.
I will have a set time that I will set up a Zoom thing that you can come in and join and ask questions if you have. So basically, I'll be sitting in my office in Colorado and waiting for somebody to come by and ask me a question. And finally,
That's really sad.
finally,
You're
each
gonna be
week,
waiting?
each week I will post a message that, well, I mean, that's what we do at office hours. I'm sitting in my office waiting for students to come by, waiting for each one of you. I will send you each week an update reminding you of where we are, what you have that needs to be completed that week.
Okay, good.
And then, if I have like a homework question, if Vanessa has what I consider a good question that everyone might want to know, I will make additional posts on the little announcement forum with, a student asked this. I won't say Vanessa asked this. I'll say a student asked this. Yeah.
On Moodle announcement forms, can we post questions and you write answers, like if they're science questions?
On the announcements, I don't know. I can make another form for interaction.
I know there's an area and then.
You have different types of forms.
Yeah.
But I would have a place for like homework or questions or something. Just make a separate form. I can totally do that. Okay, so does everybody understand what we have? Okay.
Wait.
Pause. I pause.
I'm gonna take pictures of it.
8. Oh, okay, I'm following.
Okay.
Continue. Oh. I need to answer this FaceTime as well.
It could be important. I could
I'm
do
really
that.
sorry.
If this point in time, we're in a
I told. I'm so
I'll
sorry.
send you the notes later.
normally I'd be like, no.
Yeah, literally right now. But right now, I'm trying to figure out what I'm gonna say, so. Otherwise, I wouldn't be on my phone.
There is a song to help you. Should I stay or should I go then?
Yeah.
If I stay, it will be trouble.
Yeah.
If I go, it will be double.
So true.
Oh, gosh, she's already home. Dang.
Should I stay or should I go? Okay, let's go. There we go. So we're going to talk about hydrocarbons and organic chemistry. So let's get into it. I went backward for some reason. Organic compounds. How many people like to buy organic food at the store?
It's too expensive for me.
I'm kind of with you there. Organic food at the store is a completely different meaning of organic than when we talk about organic chemistry. Organic food at the store means that they didn't use man-made pesticides, they used naturally occurring pesticides, which are often more dangerous, but they're man-made. People feel better about that. Typically, the amount of pesticides you get in organic produce is about 1/3 of the amount you get with non-organic produce. So there is something good there. Here, it means things that are carbon-based. So when we talk about organic chemistry, we're talking about the chemistry of carbon-based compounds. And so one thing you might ask is, what's so special about carbon-based compounds? Yeah. The things that life is made of are carbon-based. And so they're natural things that aren't carbon-based. Well, you can still have organic compounds that are synthetic. What's the difference in natural and synthetic?
One's real and one's fake.
No, they're both real.
I don't know.
My wife would probably say that though. Those are fake chemicals.
I actually know a little bit of the test way to do this with clothes. If it's real cotton, then it'll burn, and if it's like synthetic, then it'll melt, or like what off a rubber.
Okay, so that
makes sense.
a differentiation test, a
I know that
polymer
sounds
versus.
That's what I have.
But the difference in a natural versus synthetic, natural it occurs in nature. Synthetic means it can only be made in the laboratory, it doesn't occur in nature. Now, it's interesting, but scientists used to believe that organic compounds could not be synthesized. That is, we have, the first example that was made in the laboratory was urea, which, as you might guess from the name, is something that you have in urine. But they found that they could synthesize urea, that they could make urea. You didn't have to have it coming from a living thing. So that was actually a first step toward people coming up with the idea of life evolving from non-life. Because before that, they thought that only living things can produce these organic chemicals. But then they realized, no, we can make them ourselves. So we can make synthetic organic chemicals. A lot of people, my wife being one of them, believes that it's just better for you if it occurs in a plant. So there are lots of organic compounds. About 100,000 new ones are discovered each year. Obviously, we are not keeping an encyclopedic knowledge of organic chemistry in this class, or in any class. There are over 13 million total that are known.
Do we know that number?
No.
I have a question.
It's just there to shock and awe you about how big this could be. What's your question, young lady?
Has nothing to do with this.
Okay, what's your question?
I realize you don't do this.
Yes. The people laid off for faculty, there was me, Brett Hadley. I told you that yesterday.
No, I didn't hear that part.
Alex didn't know. Brett Hadley, Gary Reese, and Peggy Wall. Those are the 4 faculty that are laid off. All office managers were laid off. In addition to that, there were a number of staff. I remember a few names, but I don't remember them all, so I won't name them. They're reorganizing the college, so they're going to have like a school of this and a school of that. Instead of our 8 divisions, they'll just be two. It said 2 or 3, but Benita said 2 schools. And they'll have a dean for each school. And then they're going to have an office pool of 4 people. So instead of having seven office managers, they're going to have 4 people in the office pool. So Amy and I both got laid off this week. But it's effective May 30th.
Wow.
Yeah. Exciting times.
Okay, I'm listening.
All right, so why is carbon so special?
Yeah. I did get rid of some because I'm fancy at home. It's fresh. Do you want it? I'm sorry. My dad just texted me. He's a vegan. He's gonna freak out.
I really don't because I just had Buffalo Wild Wings. I'm sorry.
Okay,
That's it.
why is carbon special? Carbon is unique chemically. It's unique chemically because it forms 4 strong covalent bonds. Remember when we talked about the dot structure? The dot structure is what we use for covalent. Carbon, how many valence electrons does carbon have? If you look at the periodic table, remember we're only counting the groups that are present in the second line. So you just start from the left and go over. How many do you go over to get to carbon? 4. So it has 4 electrons, so you put them in like that, and none of them are paired. They're all available for pairing up with something else. And so you form 4 covalent bonds with carbon. And they're nice and strong and stable. There's another thing, though, that's unique about carbon. With carbon, you can make strong things that are a bunch of carbon atoms. With other things, notice the strength of this, comparatively, not nearly as strong. And because of that, you just don't find those things. An example of something you can find, apparently, sulfur 8. I say apparently because I don't know that it exists. It's very rare to find a chain of something other than carbon. The carbon forms lots of chains. So what's unique about carbon, I'll reiterate, it forms 4, not 1, not 2, not 3, but 4 strong, stable covalent bonds, and it can form long chains. We don't have that with other things. Here's an example, the ultimate example of the long chains. Diamond. Now, this picture in the bottom right is the actual physical structure of diamond, how the atoms are placed in a diamond crystal. And it's really complicated if you look at it. It's
Keep going and going.
It's face-centered cubic with a basis. But you have all of the carbons. Diamond is pure carbon with very complicated bonding between the carbon atoms. So a second thing that makes carbon special, they readily form bonds with lots of different types of atoms. Remember, how do you differentiate between an ionic bond and a covalent bond?
One shares and one.
Okay, covalent shares, right? So if you co-own something, you're sharing ownership. So covalent, they're sharing valence electrons. So it has covalent bonds and it's sharing electrons, ionic if it doesn't. But we actually differentiate that everything is somewhat ionic and somewhat covalent, but we differentiate based on the difference in electronegativities. And where carbon is in its electronegativity, it's going to pretty much be covalent with everything on the periodic table. Because the difference in electronegativity is going to be less than 1.6 pretty much with every atom. Remember, less than 0.5 was covalent. Between 0.5 and 1.6 was polar covalent, and bigger than 2 for the difference in electronegativity was ionic. So, you have, it says here, a near infinite number of different kinds of organic compounds you can make. Now, hydrocarbons are of special interest to us. Hydrocarbons are molecules that are made out of exclusively hydrogen and carbon. So, examples of hydrocarbon, here we have pentane. Now, I want you to look at this. We have three different, 3 different but equivalent ways of writing pentane. Well, there's actually the fourth way is here. Different ways of writing pentane. The top one is a picture that shows the atoms. Now, in these pictures, the big black balls are carbon, and the smaller white balls are hydrogen. It's a hydrocarbon. It just has hydrogen and carbon. And so if you look at that, you can see where the hydrogens are and the carbons are. Now, the one below isn't artistic in nature. It's showing all of the bonds. So each of the little lines is a bond, and H is a hydrogen, and C is a carbon. And they highlighted the carbon backbone. So this highlighting is just so you see, yes, we have 5 carbons in a row. How do I know I have 5 in a row? Because it said C5. Pentane, the prefix pent means 5. The ane actually means that they're all single bonds between the carbons. This final one is the simplest of all the pictures, right? But this final one, you have to know some things. This one here, you could have figured out without knowing anything. You just said, well, those lines must be some kind of connection. What connects atoms in a molecule? Bonds. They must be bonds. This one here has implied things. So anytime you have a stick figure with an angle, that angle has an implied carbon. So there's a carbon every time you have an angle. So how many angles do I have? Oh, also there's a carbon at the end of a line if it ends. So how many carbons do I have here? Well, how many angles do I have? 3 angles plus 2 ends, right? 3 angles plus 2 ends, 5 carbons. If we look here, how many angles does this picture have?
4. 5.
It has 2 angles.
Ooh, okay.
And how many ends does it have? 3. And 2 plus 3 is 5. So it has 5 carbons. This one here, I'm going to say 1 angle. It's one place where they come together. And 4 ends. So what we call this is a vertex. Each vertex is a carbon. And so we can count the carbons by looking at how many places we have two lines meet and how many ends of the lines we have. But what about hydrogen? If it's a hydrocarbon, there's hydrogens. How many bonds does a carbon make? 4. It makes 4 bonds. And so if I have a carbon right here, we have 1 bond shown. We have that bond shown with this. So how many bonds remain for it to make? If it can make 4 and it has 1 going to a carbon, how many remain? 3. And so it's going to have an implied 3 hydrogens. It doesn't show them because we can all do the math. We can all take, there's a total of 4 bonds. If 1 goes to carbon, there must be 3 going to hydrogen. So if we look at the second carbon here, it has a carbon on either side. So how many hydrogens can it have? To make 4 bonds, has 2 carbon bonds. How many hydrogens? 2. And so this one here has an implied H there and H there. And if you keep going, you'll end up drawing this. But it was all just a logical assessment. And so the bottom form is taking away all of the stuff that can be inferred and just saying we're going to have a carbon each time there's a kink and at the end of each line. And then we're going to have hydrogens, so we have 4 bonds for each carbon atom. So do you have a question about that bottom one? Because you definitely will have a question on the test that is going to ask you, what is this? No questions? All right. Configuration is our next, well, I guess I forgot. Structural isomer. I meant to highlight that too. Or was that on the previous one? Yeah, it was on the previous one. Structural isomers are molecules that have the same molecular formula but different structures. So this is called pentane, this is called isopentane, and this is neopentane. What's the difference between pentane, isopentane, and neopentane? It's not the chemical formula. All of them have 5 carbons and 12 hydrogens. But it's the structure. You have a carbon that is bonded to extra carbons if it's iso or neopentane. Isopentane has 1 carbon that instead of being connected to 2 carbons is connected to 3 carbons. And neopentane has 1 carbon that instead of connected to 2 carbons is connected to 4 carbons. So,
I get it.
so that's the difference between the iso, the neo, and the no prefix. So those are structural isomers. They're the same chemical formula, but they have different structures. Iso is the same. So they're structurally different molecules, but they have the same formula. Then we have a configuration, which is the actual way the molecules are connected to each other. So we can have differences in configuration. How many ways could we make pentane from the previous slide? 3. It's going to replace it with words. What about if we go 1 more? What would the prefix for 6 be? There are different things you could come up with, but it's hex.
Hex.
Yes.
Right. I did not know
So
that.
hexane is C6H14. How many different isomers, structural isomers, do you think you could come up with?
I'm gonna say 4.
Okay, she's going to say 4. What would you say?
3.
3. Okay, so let's do some drawing. So first, we could have 1, 2, 3, 4, 5, 6. That would be our normal old hexane. Then I could have 1, 2, 3, 4, 5, and stick one off of here. Or I could have 1, 2, 3, 4, 5, and stick one off of here. The next two would be repeating these two. Or I could have 1, 2, 3, 4, and stick one off of here and off of here. Or I could have 1, 2, 3, 4, and stick one off of here and off of here. Or I could have 1, 2, 3, and put 2 here and 1 there. Think I'm done. Yeah, I think I'm done. So that's 6 that I drew.
Oh, dang.
What do you suppose the number's going to be like for
7.
heptane?
I don't know. I'm
It's gonna
guessing.
be 12.
It's going to be much bigger, right? And if you get down to, C10, H22, or C20, H42, they're astronomically large. So here's the actual numbers. 3 for the first one. Actually, it's 5. Okay, where did I go wrong? 1, 2, 3, 4, 5, 6, 7. Oh, okay. 1, 2, 3, 4, 5, 6. I had too many. I had too many carbons. Every picture after the first one, I put 1 extra carbon in. That's why I was wrong. Embarrassing. Apparently, I can't count to 5 or to 6 because I had 7 carbons in all the first one. So it's only 5 ways of making the C6.
That is so confusing.
9
Trying to
ways.
catch the pattern here.
Oh, the pattern has to do with exponentials or excuse me, factorials. So there's not a simple pattern for you to say, oh, I see how.
Am I supposed to guess this stuff?
No, I did not expect you to. I did not expect you to guess them. What I wanted you to recognize is that it goes up really big.
Whoa.
How about we not do that one?
Yeah, okay.
Here's the next one.
To here? We're good? Okay, next we have conformation. So we had configuration, different ways that we can configure the same number of atoms. Now I have conformation, which is the same configuration, but the angles between the bonds are different. So every one I was drawing was like the one on the left. I just alternated up, down, up, down. But the bonds for a carbon atom, they're something like this. And so you can have an angle like this or an angle like this. And when you make a chain, it actually has a different shape. So that's what the conformations are, is the shape of the molecule. It's actually really important. Like the way proteins work is based on their shape, how they fold up on their conformation. So the conformation, if you look at these, the difference in this and this is that this one, instead of going down, it went up on its angle. Now,
Oh, I get it.
good. Remember that carbon always forms 4 bonds. It can form double bonds, in which case you count both of those. And so these structures indicate, where carbons are, where hydrogens are. And here we have how many bonds on the first one? 1, 2, 3, 4. On the second one, 1, 2, 3, 4. We count both of them. And so that's a double bond that we have in the 2-butene. Notice it's at E here, butene, because of the double bond. Butane, if we have only single bonds. And here's a term that you probably know something about. You've heard about saturated and unsaturated fats.
Yes.
What's the difference in your mind between a saturated and an unsaturated fat?
No.
that they're different.
The bonds.
The what?
The bonds.
Well, it is the bonds, but they tell us that we should only have,
Saturated, unsaturated.
I think it's unsaturated. I think unsaturated is the one that we're supposed to have, but I'm not sure. I could be wrong. I don't pay enough attention to that.
How about we look it up online?
Okay, you look it up online. The difference between saturated and unsaturated is how many hydrogens it has bonded to it. If you have a double bond, such as we have here in the 2-butene, the reason we have a 2 here is because the double bond occurs on carbon number 2. I just tried to write on there. Here's carbon number 1, carbon number 2, carbon number 3, carbon number 4. You just start on the end closest to the double bond and count the carbon where you first have the double bond. So that's why it's 2-butene. So you could have 1-butene as well. What would 1-butene look like?
Only one C.
It's unsaturated.
Unsaturated is the one that's supposed to be healthy?
Wait a minute.
Okay, she's still looking. What would 1-butene look like? That's an E-N-E.
Oh, only one line.
No. 2-butene means that the double bond is on the second carbon in the chain. So which carbon would have the double bond on 1-butene? The first one. So 1-butene would be 1, 2, 3, 4. So there's 1-butene. And what's the difference in that picture and this picture?
It's at a different place. I don't know what that thing is, but it's at different areas. So.
It's actually at the same place because you start numbering at the end closest to the double bond. And so those are actually just the same picture rotated by 180 degrees. So those are both 1-butene. So butene is unsaturated because instead of having two hydrogen on those middle 2 carbons, there's only 1 hydrogen on them because the carbons have a double bond. So unsaturated, if you break the double bond to make it a single bond, you could add 2 hydrogens. And then it would be saturated if it had all the hydrogens you could put on it. So that's the difference in a saturated and unsaturated fat, is having double or even triple bonds on the backbone, as we call it, on the carbon chain. Okay, I did not queue up woo clap today because I knew we were going to be short on time because of the introduction. What is the chemical formula for this structure? So let's start with, there's only really one question to answer since they all have a different number of carbons. How many carbons does this have?
5.
Okay, 5 is the right answer. How do you know?
Because it's got 5 points.
Has 5 points. 1, 2, 3, 4, 5. So the answer of 5 carbons is correct. So yes, that is C actually. I thought you were saying C because I had C here for carbon. I didn't look at which answer was A, B, C. Hydrogens. Now, since you know the answer C, you could know, but let's count them anyway. How many hydrogens do I have on carbon number 1? The one that I labeled 1. How did you come up with that? She's right. How did she come up with it?
Ask the question one more time.
How many hydrogens are on carbon number 1?
Right.
Well, it's 3, yes, but I want to make sure people know how to get there. So
The one, you got the number 1 dot, and then you've got 4 dots that are supposed to be around it. It's connected to the 1 carbon, which is number 2. So there's 3 spaces left.
Oh, makes sense.
So you want to make that dumb?
1 dot needs 4 dots around it. It's got 1 dot in it, so 4 minus 1 is 3. 2. Carbon number
So here I've written down what she said. It was a perfect explanation.
Yeah, thank you.
Carbon has 4 bonds. That's our rule that we start with. So we look at carbon 1 and it has 1 carbon bond. That is, it's bonded to carbon 2. And so if it has 1 carbon bond, then you have 4 total bonds minus 1 carbon bond. You have 3 bonds remaining. If it's a hydrocarbon, those have to be going to hydrogen. So it's 3. Now, if we look at carbon number 4, how many hydrogens are bonded to carbon number 4?
Wait, let me guess.
I want you to try to figure it out. And
Well, that's
I know
what
Vanessa
mean.
knows the answer,
Oh,
so don't
shit, I
answer
don't have
Vanessa.
an execution sheet. I'm gonna figure it out.
Okay.
Smart for me.
So explain to us as you're figuring it out.
Wait, no, I can't do that because I don't even understand myself. Hold on. I'm thinking. Okay. Which one are we looking for?
Carbon number 4. How many hydrogens are bonded to carbon number 4? 2 is correct.
There's 2 left.
Right. You have 2 carbons bonded to carbon number 4. 3 and 5 are bonded to 4.
Would that answer be the same for 2 or 3?
Yes, it would.
Make sure, okay.
I just went to 4, so we weren't.
Right.
All right. Gasoline. You know what is well timed? The whole stock market plunging is not well timed. Right? I'm selling my house, the stock market plunging. How's that work? But here's something that's well timed. It's spring break, and what's happening to gas prices?
They're going up.
No, they're going down.
They're going down.
Why are they
Because
going up?
They're going down because Saudi Arabia is dumping oil on us.
Why is Saudi Arabia doing that?
I'm not sure. I haven't paid enough attention. We got everybody's paying
Saudi
attention,
Arabia.
especially to the COVID-19 virus.
COVID.
I have a quick question after you explain this. Because
Okay.
It's not pertaining to it.
So, crude oil is what they pump out of the ground. Crude oil is a hydrocarbon, but it's not just one type of hydrocarbon. You have all different kinds of hydrocarbons. You have lots of different carbon chains. Some will be short chains. The shortest chain possible is methane. Methane is a single carbon. There's no chain there. Long chains are also there. And so it comes all together. And so what they do with this is they heat up the oil. There's a little inherent danger in heating up the oil. Why would that be?
Because it'll blow up.
It'll burn. So you have to make sure you don't have everything you need for burning. We didn't actually talk about redox reactions, but burning is a redox reaction. You have to have oxygen, and you have to have the heat, and you have to have the fuel. So if you do this without the oxygen, you can heat it up and not have it burn. So it's kind of tricky, it's kind of dangerous, but as long as you don't have oxygen there, it's going to work. So they heat up these hydrocarbons to make them vapor. So you have vaporized oil.
Vaporized oil?
Yep. See where it says crude oil vapors?
Wow.
So they heat it up to vaporize it. And then they put it in this thing here that's called a fractioning tower.
Is that good for?
Oh, it says it right there.
Is that good for our economy that Saudi Arabia is doing that?
Generally speaking, no. Right now, the United States is actually the largest producer of oil in the world. And this will reduce us because it's not as cheap for us as to produce oil as it is for them. So they can do this and still make money, whereas it puts us into a negative situation.
We're already suffering.
Yes.
So what's going on with the fractioning tower?
We're doing it on purpose.
When you vaporize the crude oil, the temperature at which it will condense means that you have molecules stick together, depends on how long the chain is. Long chains will condense, will form a liquid at a much lower temperature. Short chains will produce a liquid at a much higher temperature. Or excuse me, I said that wrong.
Yeah.
I said that wrong. The short chains will condense at a low temperature. The long chains will condense at a high temperature. And so the things that condense at a really high temperature, that's tar. That's the stuff they use to make our roads out of, right? They use it to bind gravel together.
It's used on roofs too. Roofs.
Roofs. Okay.
Roofs.
I thought you said roofs, and I was like, but that's what I said.
No.
Yes, roofs.
It's not accent.
Okay. You get to be shorter chains than you have the oils we use for lubricating things. Even shorter, you have diesel fuel. Even shorter, you have kerosene. Even shorter chains, you have gasoline. And then the shortest ones here, natural gas. They're still in gas form even at room temperature. So that's how we get the different grades of oils. It all comes in this barrel of crude that was pumped out of the ground. And then they heat it up and they fraction it off to get the different types. So when you see the gasoline refinery, they're not just producing gasoline, they're separating out the different things. Question, Alex. Yeah, you said at the end of this. Yeah.
Yeah, so the quizzes during our online information could be good.
Yeah. I don't have a plan for
We need
quizzes.
intermission.
Okay.
This is for the rest of the year.
Okay.
Oh, okay.
So no quizzes or
Right.
online or
Right, I
no
don't-
quizzes?
I don't have a plan for quizzes. That's correct.
Okay.
That very well could save my grade.
Yeah.
That will save my grade. It's not very well. It will save my grade.
Okay. I don't know why I have this repeated. I know why. I thought I moved them. I copied and pasted, but apparently I didn't delete. So we talked about the difference in saturated and unsaturated. Unsaturated, you have a double bond, or you can have a triple bond. Or in this case, we have what's called a benzene ring. A benzene ring is,
The ring of benzene.
it is, that's correct.
I know. I'm with
How
it.
many carbons do you see in this structure right here?
Wait. Six.
6.
Hey, good job.
Genius.
How'd you come up with 6?
Because I counted
Counted what?
the points.
Right.
Good job.
Counted the points. There were 6 points. Now, if we look at the bonds, how many hydrogen are connected to this atom?
Sorry, what?
How many hydrogen are connected to this atom I marked?
Whoa.
Just one. Just one, because how many carbons are connected? How many carbon bonds are there? Not how many carbons are connected now, but how many carbon bonds?
Okay, well.
How many bonds can a carbon have?
2, 4.
4. How many does it show in the picture?
There's 2.
There's 3 because this is a double bond. That's 2 bonds.
Oh, I didn't know that's what
Yeah,
that was.
that's why we go over it.
Okay.
So it has 3 carbon bonds. So how many hydrogen remain then?
Many.
Just 1.
Just one.
Because 4 minus 3, 1.
It's a lot.
There's a lot.
Now, what's the difference between these two structures? It has this little arrow
Their arrows are pointing in different ways.
between the two hexanes.
What's the difference?
Actually, they're not hexane because hexane is a ring.
The hydrogens are in different places.
It's actually not the hydrogens, it's the double bonds are in different places.
Well, that's what I meant.
And so this is called resonance.
Is it the ISO whatever thing that we just went over? The shape is different?
It's the same shape, but where the double bond is different. And so it's a resonance. What actually happens is the double bond is constantly shifting around. And so they draw this structure on the right for the benzene ring, that hexagon with the circle inside means that you have 3 double bonds that are constantly moving around. I'm going to miss you. Okay, well, I do want to show one last thing. I want to show this. Functional groups. You do not have to memorize this, okay?
Oh, okay.
Thank you.
But it's, I think, very useful to know what the difference is between an alcohol and, for instance, an ester, or an amine, or a ketone, or ether. And so alcohols have OH groups on them.
And the other ones don't.
Well, if you look at
That one
the
has
carboxylic acids, That has an OH, but the carbon has a double bond to an O that has the OH. That's what makes it a carboxylic acid. Okay, I have two questions.
Remember that?
Sure.
Yes.
Alcohol is OH, and there's OH in alcohol. Then over here with the
Carboxylic.
it says OX. That reminds me of oxygen, and there's 2 oxygens in that. Boom.
Period. Science.
All right. So
That slide where you just skip through really fast, is that important?
this one here?
Yeah.
Well, a heteroatom is simply any atom that's not hydrogen or carbon. I'm not going to ask you about that.
Okay.
Functional groups is what is on this.
Okay.
And so this is what was important there. So you don't have to have this memorized, but it is something that's very useful. As you go, I do want to point out something from yesterday's lab. Was yesterday's lab hard or easy?
Easy.
Easy. Was it something that you learned from?
Yes.
Is it something you could do with grade school students?
Yeah.
Absolutely. What did I use? I used red cabbage that I boiled in water to make my indicator. And then I just used some standard household chemicals, things that you're going to be able to find at your school.
Yeah.
Go to the janitor's closet, you'll find half of the stuff we used. Because when you're a teacher, you're not going to have big budgets. You're not going to have all kinds of cool stuff.
Facts.
But doing things like that is very accessible. The kids can see the colors. They're like, wow, there's something different. Are they going to know this is more acidic than that? No, they're not. But they can start to learn.
Yes.
You know what? I hope you have a good life.
Thank you.
Well, nice to meet you.
Yeah,
Oh my God.
I know. Well, seriously, we'll probably never see each other again.
It's true. And now it's gonna go be
Have
sad.
fun in Colorado.
Thank you.
Have fun in the mountains.
I
In the
will.
snow.
And you guys have a great rest of the year.